Okay, so here is the review for 1A. So we're going to be going through all the vocabulary stuff, something you guys really struggled with. Okay, so we said a line contains point L. So point L, which is -4, -4. Here's point L. And M, which is 0.23. Here's our M. And so we do our best to draw a line through that. Okay. Line Q is in the same coordinate plane, but does not intersect LM. Q contains point N. So what do you know about line Q and LM if they don't intersect and they're in the same plane? So Q could pretty much be anywhere. But what we know about line Q is it's going to be parallel. Okay, and we'll talk more about that. And the other part of our drawing is that, so here's our line Q in cursive, and it contains point N. So point N could just be a point on that line. So again, all you have to do is draw two lines. They don't intersect, so they're going to be parallel. And line N is on line Q somewhere. So just kind of an interesting one. Number 9, it says find the length of segment AB. If I look at this is split up into 4 parts. So each part is 1/4, so that's going to be 1/4, 2/4, 3/4, 4/4, 5/4, which is actually the distance from A to B is 1 1/4 inches. Number 10 says draw and label a figure that shows plane R contains both lines Q and AC. Okay, so we have plane R, our little cursive R over here, contains both line Q and AC that intersect at B. So, contain lines Q and AC, and we know that they intersect, so this is A, C, and they intersect at B. It says name 3 collinear points. A, B, A, comma, B, comma, C would be your 3 collinear points. Because they're on the same line. All right, number 11. It says name a point that is not coplanar with BDC. So BDC are in plane P. So the only ones that are not in plane P are F or G. You can have one or the other. You don't have to have both. What's another name for plane P? Well, another way to name it, name a plane would be by 3 non-collinear points. So we'll say you could have had A, B, D, or you could have B, D, C, any combination, D, E, C, any combination of those points, A, B, E. So basically any combination of points, just not A, B, C. And the problem is these always have to be non-collinear. It says give another name for line L. A line can be named by 2 points. You could have AB or BA, BC or CB, or you could have AC. Okay, but you only name a line with 2 points. It says name the intersection of lines L and M. That's going to be B because they intersect at a point. Name 3 points that are collinear. A, comma, B, comma, C. Make sure you have commas in between because they're separate figures. So it says how many planes are shown in the figure? There are 5. There's the one down here. There's the one to the side here. There's this side here. There's the one in the back. And of course, there's the one in the front. So there are a total of 5 planes. All right. Name the intersection of plane A, B, D. So that would be this one here. And C, A, L, which would be the one in the back. And if you look, you can see that they intersect right here. It's the edge that they have in common is AB. So you could write segment AB, or because planes are actually continual, they go on infinitely, you could do line AB. All right. And then the next thing is name a point that is not coplanar with GAB. So GAB is our front, which means anything on this surface is coplanar. So you have 2 choices. You could do C or you could do L. So C or L. Okay, it doesn't have to be one or the other. You don't have to do both, just one or the other. All right, provide the appropriate vocabulary. So non-adjacent angles formed by intersecting lines are going to be vertical. Angles, okay, it's C-A-L, not V-E-R-T-I-C-L-E, okay. Adjacent angles whose non-shared sides are opposite rays, so they're adjacent angles, which mean they share a side, but their other sides, one goes in one direction, one goes in the other direction. That's going to be a linear pair. Angles that have a common vertex, a common ray, so they have that in common, but nothing else in common, are called adjacent angles. Alrighty. For A, it says name an angle supplementary to X, Y, W. So X, Y, W, name an angle that would be supplementary. So I'm looking at linear pairs because we don't know the measures. So it's a linear pair with this angle here. So one of the possibilities is angle XYU. Don't forget your angle symbol. Or you could also, it is also supplementary to this angle, which is WYT. So either one. You have to have both. Name an angle complementary. So remember, complementary angles are a pair. Okay, and so it's name an angle complementary to WYV. So WYV would be this angle right here. I know this angle is 90 degrees, so an angle that's complementary, and it would be complementary and adjacent, would be this angle right here. So XYW. Or it could be angle WYX. Let's name a pair of obtuse vertical angles. Yes, we're going back to that because you guys had a tough time with that. So first thing I do with this is I look at my intersecting lines. So do you see that this line and this line intersect? The rest of these do not keep going. So I know this angle and this angle are vertical, and this angle and this angle are vertical because they're formed by the same 2 lines. It says obtuse though, so we're going to go with these two angles here. So angle UYX or XYU and angle TYW or WYT. Okay. It says name the sides of SYV. So SYV. Sides are rays, so the sides that make up it are this side and this side, which is ray YS and ray YV. Be conscious that the ray symbol always goes to the right. And these always start with the endpoint. Next thing is name a pair of opposite rays. They have to be collinear. I go to the lines. So it's a name pair of opposite rays. Sorry, I got a little distracted, guys. All right, so I look at this line right here. And I know I have a ray that goes this way and a ray that goes this way. So YU would be one, and the opposite ray to that would be the one that's going in the other direction, YW. Or you could have this one and this one along this line. See that there's a point in between, so we could do, or you could have YX and YT. Okay. Last one of these for this diagram is name an angle that's a linear pair with TYS. So TYS. So we're looking for one that's on the same line that's adjacent. So I could have an angle on this side or I have an angle on this side in theory. I know it's going to have to be, see, it's going to have to share this line with TYS. So I look here and I'm like, oh, okay. Well, this angle here, is a linear pair, so XYS or SYX. Problem is there's, so if we're looking at the other side of TYS, do you see that there's no line right here? So we don't have enough information. So that's actually the only answer with that one. So it's just that one right there. Okay. Last piece of vocabulary, so that's the last part of this one, is this true or false. Angle 5 and angle 3 are a linear pair. That is, or vertical. That's not true because 5 is made up of this green line and this purple line. 3 is made up of that green line and then that blue line. So that's not going to work out. So that is a big false. 1 and 5 are a linear pair. If I mark each line, do they make a straight angle? Yes, they do, so that's going to be true. 4 and 3 are adjacent. That is true. They share a side, the side right here. 1 and 4 are vertical. That's true because they're both made of a green line and a magenta line, if you will. So that is also going to be true. And then angles 3 and 4 are a linear pair. 3 and 4, when you put them together, they don't quite make a straight angle. They only, or they're just a little bit short. So that one is actually going to be false. And so that's it for the vocabulary portion. The only thing that we're running short on is measuring an angle, but that'll be reviewed in constructions. So